Hello Precalc students, and welcome to a video on sum and difference formulas using reference triangles, and these are looking at expressions that involve both a sum or difference of sine, cosine, or tangent and some kind of the angle is given to you as some kind of an inverse trig expression. So we do have to kind of keep in mind our restricted domains when we work on that. All right, so the first thing I want you to notice here is that when you're looking at this, you're looking at the inverse sine, and remember the inverse sines are always angles. So this is essentially an alpha, and this tangent inverse is essentially a beta. So what we're looking for is really the sine of alpha minus beta, which makes sense since we're in the section that deals with sum and difference of sines and cosines. That is just going to apply the sine of alpha minus beta formula. So it's going to be the sine of alpha cosine of beta minus sine of beta cosine of alpha. So let's just expand this out so we kind of have an idea what we're looking for. So we're looking for the sine of alpha times the cosine of beta minus the sine of beta cosine of alpha. So to find those four little pieces that we need, we're going to make two reference triangles, one for alpha, one for beta. Okay, so let's work on our alpha triangle first. So we know that the sine of alpha is negative 4/5. Okay, so that's what follows. If the inverse sine of negative 4/5 is alpha, that means that the sine of alpha is negative 4/5. But because that came from an inverse statement, we have to remember that the inverse sine is only defined from here to here. So we want the sine of some angle to be a negative value, and that means a negative y value, which means it's got to be in the fourth quadrant down here. Okay, I'm going to say that again. The inverse sine is restricted to the first. Another way of showing this would be it's restricted to the first and the fourth quadrant because it's an inverse sine, and that's the restricted domain for the inverse sine. The sine over here, the sine is a negative value only here or here. So that's another way of thinking of how to get to that fourth quadrant, and that's important for the signs, the SIGNs of these, to be the right sign, positive or negative. Okay, so let's draw our alpha triangle in the fourth quadrant. Reference triangles always go perpendicular to the x-axis. I'm going to call this alpha. Technically it's alpha reference, but it works the same. The sine by definition is y over r, so our y is negative 4. The r is 5. And that makes sense since we're in the fourth quadrant. It should be a negative value for y. And so this is a 3, 4, 5 triangle, and this is going to be a positive 3 over here. And so there's our alpha triangle. Okay, now we're going to do the same thing with the beta triangle. So we know that the tangent over here, the tangent of beta is 3/4. So we know that since it's an inverse tangent, we know that it's also got the same restriction, except that it doesn't include the endpoint, something like that. We know that this one is positive, so it's going to have to be up here. Okay, so to put that another way, we know that because it's the inverse tangent, and that's restricted to the first and fourth quadrant, it's got to be here or here. We know that since the tangent is a positive value, that only happens in quadrants 1 and 3. So the only possible quadrant for these both conditions to be met is quadrant 1. So we're going to go ahead and draw a first quadrant triangle that we're going to call our beta triangle. Okay, we know that the tangent of beta is by definition y over x, and so in the first quadrant they're both positive, and so it's going to be a 3 for the y, a 4 for the x, and this is another 3, 4, 5 triangle making 5 for the hypotenuse. Okay, now armed with those triangles, it should be pretty easy to finish the problem. The sine of alpha means we look at the alpha triangle and the sine of alpha is negative 4 over 5. So negative 4 over 5. The cosine of beta brings us to the beta triangle. Cosine is positive 4 over 5. Minus the sine of beta, which keeps us at the beta triangle. The sine here is 3 over 5. And last, the cosine of alpha brings us back to the alpha triangle, which is a positive 3 over 5. The cosine of alpha is positive 3 over 5. Okay, and then just simplify this. We have negative 16 over 25 minus 9 over 25, which equals negative 25 over 25, which is negative 1. I hope you found this video helpful.